In this session, we're going to discuss or apply pigeonhole principle in solving some problem. So let's have a review first. What is a pigeonhole principle? So in our last video lecture, we discussed pigeonhole principle as to determine how we're going to organize our data or our pigeon in a hole or in a container. And through pigeonhole principle, we could determine the worst case scenario to meet the desired arrangement of our data, of our pigeon, of our the collections of items that we have. Okay, so for example, so what result do we get when we try to distribute the circle in our square? So I could put the first circle in the first square. I could put the second circle in the first square. The third circle for the first second square. Fourth circle on the second square, and the fifth is for the fourth square. So therefore, we have two circle on the first square, two circle on the second square, zero on the third, and this should be one on the fourth square. Again, this is one. So this is the one possibility of arranging our circle in our square container. But in case I want to have one circle to one square, so what will happen with our arrangement? Can it be done? Hmm. So first circle, first square, second circle, second square, third square for the third circle, and fourth circle for the fourth square. So how about the fifth circle? How will I go? Where what container I'm going? What container will contain it? Okay. So definitely it will not be one to one since we have fifth circle and it should be contained to another container, to one container. So therefore, instead of one circle to one square, it will be one square contains two. Okay. So this is another way of arranging our, our circle in our square container. Some will have one circle, a square have two. And based on our two examples on how we arrange it, we could say that at least one square may contain may contain two circles. Okay, at least one square contains at least two circles. In this slide, it's true. On the previous slide, even though one square has zero circle in one container square, but the other have two. Am I right? For the first square, we have two circle rather. On the second square, we have two circle. Okay, so we are defining that at least two circle in one square. Okay, so that's a criteria, and this criteria was determined using pigeonhole principle. Okay, and again, using pigeonhole principle, we could interchange kung alam natin yung not interchange kung gusto natin malaman kung gusto natin ma-meet yung requirement natin, we need to define how we're going to do it. What is the worst case scenario? So using pigeonhole, we could determine, okay, the arrangement. Okay. Now, so another thing that we discuss in pigeonhole, so we have this formula. So given M item and N container, if M is greater than N, there is at least one with, okay? So this symbol is ceiling, means round up, okay? Ceiling of M divide N items. So for example, we have 4 items, we have 3 containers, and using the formula, the ceiling M over N, we have 1.33 items. And since we have ceiling function, so 1.33 round up, it's 2. So it means there is at least one container that contains 2 items. So that's the meaning of this formula. Okay? So it defines how many items in one container. Okay, and it defines the relationship of the container with the number of items that that it could contain, and the population of our data, or of our the one that we are that we're going to put in our container. Okay, so let's have problem number 1. Show that if there are 30 students in a class, then at least 2 have last names that begins with the same letter. So for example, we have 2 students that start with A or B or C. Okay, so that's what is asked from us. So we need to prove that at least 2 surnames start with the same letter among the 30 students. Okay, so now let's define our M and N. So the population is definitely 30. Okay, and the number of containers, it is based on the number of letters, because it could be group A, group B, group C, group Z. So we have 26 distinct letters. So it means we need to have 26 distinct containers. Okay. So using pigeonhole principle, okay. So again, okay, floor a ceiling of M over N less than or equal to your number of items in a container. So in this example, in our container, at least 2. So that's why less than or equal to 2. Okay, and 26 is the number of containers. So why just M? Just to show you that we're going to look for M, and it should be less than or equal to 30, so that this problem, that we could meet the at least 2 have last 2 names from the 30 students. So that's why we're going to use this formula. Okay, so ceiling of M over 26 less than or equal to 2. We could rewrite it as 26 times 2 minus 1 plus 1. Okay, bakit may minus 1 to? Bakit may plus 1? Don't forget the effect of the ceiling. The ceiling round up. Okay, so it means, okay, so it means yung 2 na yun is basically 1 point something something. So that's why we subtract 1 from 2. Okay, and para ma-assure na mas mataas yung M natin, so we add 1. Okay, we add 1 sa 26 times 2 minus 1, so that M is bigger than 26. Kasi kapag hindi natin nag-add 1, it's still the same as with 26 ang result. Don't forget, dapat mas mataas ang numerator para mag-round up. Okay? So, the result is 27. So, it means, after 26, pagdating ng 27, we are sure that there will be surname that starts with the same letter. Okay, that will be the worst case scenario. Okay, so we're sure after the 27th, okay, there are 2 students that have the same letter on same surname that begins on the same letter. Okay, so therefore this is true. Okay, so we show that 27th student, 2 surname with the same letter, start letter. Okay, now problem number 2. A bowl contains 10 red balls and 10 blue balls. A woman select balls at random without looking at them. So letter A, how many balls must she select to be sure of having at least 3 balls of the same color? Okay, so let's answer first letter A. So our population is definitely 10 red balls, 10 blue balls, so it's 20. Okay, and the number of containers, it could be either blue or red. So we have 2 containers. But how many items need in one container so that tapos na tayo sa pag-arrange? From the 20 balls, 10 red and 10 blue, okay, paano kailan natin mamimit yung requirement that at least one container contains the same color? 3 red ball, 3 red blue, or 3 blue balls rather. 3 red balls or 3 blue balls. Okay, so using the pigeonhole formula, okay, so M we don't know, so it will be based on the 10 red balls and 10 blue. Okay, and the number of containers is still 2, and the number of same color is 3. Okay, so 3 balls in one container. So that will be the worst case scenario. Okay, so using the same approach, so let's evaluate this ceiling as 2 times 3 minus 1 plus 1. The result is 5. So it means after the 5th ball or after the 4th ball, okay, so on the 5th ball, definitely we're going to have 3 balls with the same color. That's the worst case scenario. Okay, bakit? So pwedeng mangyari would be the first 2 balls will be red. Then the next 2 balls will be blue. So we have 4 na. So on the 5th, so since dalawa ng red, dalawa ng blue, on the last, either it will be red or blue, one of this color will be 3 balls with the same color. Okay, so that's why the worst case scenario is drawing 5 balls. Okay, and after the 4th or on the 5th ball, that's the time we're going to have 3 same color balls. Okay, so that is our answer. Okay, how about letter B? So again, 10 red balls, 10 blue, but now the container is just 1. Kasi ano ang tanong, how many balls must she select to be sure of having at least 3 blue balls? So we have one container that contains red balls and blue balls. What will be the worst case scenario wherein doon pa lang tayo makakaroon ng 3 blue balls? The worst scenario would be we're going to draw 10 red balls first before we could get 3 blue balls. That's the worst case scenario. Get all the red balls first, and then definitely, since we don't have red balls on our choices, definitely we're going to have blue balls after the 10 red balls. Okay, so that's the worst case scenario. So therefore, 10 plus 3, so 13 balls. Okay, that's the worst case scenario. So at least 13 balls. Okay, we need to draw from the 20 balls to have 3 blue balls. Okay, in our container. So that's problem number 2. So again, pigeonhole determines the worst case scenario to meet a certain scenario or to meet our requirement in arranging our pigeon or our items. Okay, so now let's move on with problem number 3. Show that if 7 integers are selected from the first 10 positive integers, so it means 1 to 10, there must be at least two pairs of this integer with the sum 11. So from 1 to 10, okay, so we're going to pick 7 integers from 1 to 10. And if we're going to pair one integer among the 7 integer, if we're going to pair one integer to another integer within the 7 integer, it will give us 11. Okay, so to show that this is correct, this is true, okay, and that we could show that this is true, so we need to get first um, the pair that will add 11. So these are 1, 10, 2, 9, 3, 8, 4, 7, and 5, 6. Okay, so these are the pairs that will add to 11. Okay, so let's get 7 integers from 1 to 10. So I want to get the first 7 digits, 7 integers, which are 1 to 7. So is there an integer when we pair with another integer within this set will give us 11? 1, 2, no. 1, 3, no. 1, 4, no. 1, 5, no. 1, 6, no. 1, 7, no. 2, 7, no. 3, 7, no. 4, 7. Yes, we have. So therefore, we have at least one pair that satisfy the sum 11. 4, 7. 5, 6. Same. Okay, so based on this, we could. Another example. So instead of having the first 7, so just random. So I have 2, 3, 4, 5, 8, 9, 10. So is there a pair of integer that will add to 11? Yes, 2 and 9, 3 and 8. Okay, so we have two pairs. So as you can see here, 7 integers, getting 7 integers from the set, okay, from the set definitely will give us when from the 7 integers that from the set, okay, and if we're going to pair that 7 integers, there is a possibility a pair will give us 11. So A is correct. How about B? Is the conclusion in part A true if 6 integers are selected rather than 7? Is 6 enough? Okay, is 6 enough? 6 integers is enough to say that there is a pair of the integers among the 6 with the sum of 11. Okay, so to answer this, we're going to use the pigeonhole principle. Okay, 1, 2, 3, 4, 5, 6. Is there a pair that will add to 11? Yes, 5 and 6. Correct. Okay, so using the pigeonhole, m divided by 2, the ceiling of m divided by 2 equals 2. Okay, to 2. Okay, so basically n is 5. Okay, so m divided ceiling of m divided by is equal or less than or equal to 2. So what is m that will yield to two item in a container? 6. Am I right? So ceiling of 6 divided by 5. Oh, sorry. Yeah. 6 divided by. Okay. Sorry. Ceiling of. Okay. So we have 5 containers. Ceiling of 6 divided by 5 is 1 point something. Round up, it's 2. Okay. So therefore, the minimum number of integers is 6. Okay, so therefore, it's true. Okay, based on the formula, the ceiling of m over n less than or equal to the number of items. And okay, N is 5, okay? 6 is M, and 2 is the number of item. When you substitute into our equation, it yields the correct answer. It satisfies the equation. So therefore, the statement B is true. Okay, problem number 4. How many numbers must be selected from the set 1, 3, 5, 7, 9, 11, 13, 15 to guarantee that at least one pair of this number add up to 16? This is almost the same as problem number 3. Okay, we're going to pair integers to give us 16. So we're going to choose values from these 8 items in our set, okay? And then if we're going to pair it, and from that values that we choose, so when we pair it with each other, so it will yield a 16. It will yield 16. Okay, so to answer this again, we're going to look for the pairs that will yield to 16. So how many? We have 4. 1, 15, 3, 13, 5, 11, and 7 and 9. Okay, so it means, okay, since we have 4, so we have 4 pairs, so it means we have 4 containers, and our number of items need, in one container, we need 2 items. So 4 container, 2 items in a container, using the formula pigeonhole formula, what will satisfy that equation? Minimum value of M. It's 5. Am I right? Okay. So if we're just going to choose 4, so if we're going to choose 4, 1, 3, 5, 7, it will not yield 16, or 9, 11, 13, 15, it will not yield 16. But if you're going to add one integer, okay, 1, 3, 5, 7, and then get any value from the second group, second set, we're going to have 5. And definitely, we're going to have sum equal to 16 when we pair a certain integers. Okay, so that's problem number 4. And that will be my last example for pigeonhole. So if you have some question about pigeonhole, so kindly kindly send me a message. Thank you. Thank you for listening, and see you on the next video lecture.